we're going to give you a hint of Dante Software Solutions that we Audinate develop. Well, Dante experts are going to provide an overview. Here's the expert. I just give the impression to know something. And the QR code is for a free trial of Dante Application Library. We'll get into that. So the agenda will cover who's Audinate, what's Dante, and what software solutions do we have available. And Andy will do a small demo or hands-on with Dante Application Library. So who is Audinate? It used to be a small Sydney, Australian company from Sydney. Now has been growing up quite a little bit. We are not even 200 around the world. Exciting things is that, well, we used to do audio, now we also do video, and most of the video development is being done here in Europe between Cambridge and Belgium, Brussels. There's something that I usually like to say is that Audinate and Dante is not a product that comes from the AV world. Actually, the people who founded the company and created the product, they were IT engineers. So it has been designed as a real network product. It's on stock, we don't really care that much, and we started the IP revolution. And well, as I said, we acquired a Belgian company this year, which is called Silex, and they are going to be developing the hardware devices, hardware video devices for Dante in the coming future. So a quick overview of where you can find Dante products. So Dante, it's a technology, and you can find that technology in products made by other manufacturers. We don't really sell products ourselves. Well, you can buy some software things from ourselves and some small adapters, but otherwise the majority of the Dante-enabled products are branded from Yamaha, Shure, Midas, whoever. So for more than 500 manufacturers, more than 3,000 products, etc., and has kind of made Dante the de facto standard for AV over IP. So, why Dante? What's Dante? So, something that I like to say that is not here is Dante, for me, it's a network transport solution where you can exchange audio and video over a standard IT network in a synchronized way with super low latency. That's the product definition. So it's a standards driven, so Dante is proprietary technology, but most of the things that we use are based on well-known network standards or protocols that are standards, like MDNS for discovery, PTP for clocking, etc., etc. There are some blocks that are proprietary technology, but we use as much as we can standards. Reliable, so it's, as I was telling before, it has been running for years, so now you can find Dante products anywhere in the live market, in the commercial installation, unified communication, classrooms. So the interesting thing is that it's the same technology that you can put in different places and it will work the same way. It's just a networking technology. So Dante products are just standard network products. So you can actually, one of the main things about Dante is that you can reuse any existing IT network and just plug Dante devices there, the same way you would plug a printer, a laptop, or whatever. So Dante can coexist within the same network with other gear. And real tools and secure. So of course we have been doing this for a while, and we have a bunch of software applications that allow you to control and secure the Dante network. So the whole control thing, it's a big part of the ecosystem as well. It's not just the fact that you're able to send audio and video from point A to point B, but the fact that you can control and manage that whole network, that's also a strong business argument. And just to give you an example of what could look like a typical Dante installation in the live world. So you could have a computer with a software running Dante natively, a mixer with Dante, a computer with Dante controller is our software for making the connections on the network. Dante AV cameras, because as I was telling before, since a few years now, we have also been expanding out of the audio world and into the video world. And so monitors, computers, stage boxes, amplifiers, whatever, the thing that everything is just plugged into an IT network, and all the media and control and clocking will be shared over that standard IT network. So how does Dante work? The Dante hardware implementations, they just are small boards like this with components on top of it. They will just receive audio samples from whatever equipment they are putting in. They will encapsulate that data to be transferred over the network, and they will also timestamp that data with PTP. So do you guys know what PTP is? Just to give you a hint. So PTP is not something that Audinate has invented, not at all. And PTP is actually, it comes from the IT world. It's what we use to synchronize computers and servers on the research centers, particle accelerators, and things like that. So those packets get into the network and then will end up reaching another Dante device that will be able to do something with them. Again, you don't need special switches or networking stuff to do Dante. And so one of the main things that makes Dante particularly interesting is the way we combine the clocking and the latency to make things work the way you would expect it from the acoustic audio world. So as I was saying before, Dante devices, they are synced together using PTP. So that specific protocol that actually allows you to get perfect syncing between the devices. So all the devices are running with the same exact time reference, up with a precision up to 0.1 microseconds. Then you are going to, all the Dante devices are going to determine a latency setting that you are going to be able to put in Dante controller. Then the combination of the fact that the devices are in sync plus the fact that the devices use a fixed latency buffer makes that whenever a Dante board gets an audio sample, that sample is, let's say, it arrives at 10:30. We know the exact time because everyone is in sync. We transfer that over the network. That will take whatever time, usually something slow, because Dante is designed for local networks. So local networks, traffic usually tends to travel fast from point A to point B. That traffic, that sample arrives at destination, and it's actually kept on a buffer, and it's played out at 10:30 plus 1 millisecond by default. The default Dante latency is 1 millisecond. So from where we get the sample until when the sample is played out, we know the exact time, the exact latency we're gonna apply to that audio sample, which actually makes, so it seems simple, but thanks to this, so if you have the same audio source sending Dante to two speakers, because this latency is the same for the two devices, when those two speakers will play the audio out of the speaker, that audio will be in phase. As simple as that. And okay, so Dante, as I was saying, Dante is well known for hardware implementation. So we have our small boards that have more or less channels that are inside wireless microphones, mixers, amplifiers, whatever. But today we are going to talk about Dante as software. So there are several flavors of Dante as software. The first one is Dante IP Core. We're not going to be really talking about that much. So that's a solution for manufacturers. So manufacturers that have their own hardware platforms that run with their own FPGA, they can just get a bunch of code and run Dante out of it. So it's what you get the best performance out of it from any software implementation. But then we have two other platforms that are called Dante Embedded Platform and Dante Application Library. So Dante Embedded Platform, just to make it simple, is Dante for Linux. So again, it's another OEM platform. So we sell the Dante embedded platform to manufacturers that are actually developing any kind of box that runs on Linux. So they can actually make that box become a Dante device via software. Several architectures, channel count from 1 to 128, several sample rate up to 96, latency between 2 and 8. So all of those settings, I mean, because you're going to be running Dante on Linux on your own platform, depending on the processor that you have on your own platform, you are going to be able to get more channels, better performance, and things like that, or not, because it's going to be shared resources between the Dante layer and your own application layer. And the third option is going to be Dante application library that actually Andy is going to do us a small demo hands-on on it later. So what is Dante application library? It's Dante for Windows and Mac. So you probably already know Dante Virtual Sound Card, which is one of our products that you can install on Windows and on Mac OS. Dante Virtual Sound Card allows you install it on a computer. That computer sees a sound card, and the network sees a Dante endpoint. So it's just a way of getting audio in and out from any audio software on a computer that is able to use a sound card. Dante application library is slightly different in the way that you actually are going to integrate Dante within your application. So your application is not running, nothing happens on the network. You start your application, poof, a Dante device appears there automatically. So you don't need to use DVS. It's kind of like an integrated DVS directly within your application. It's an SDK. And again, the performance of Dante application library, because it runs over Windows or Mac OS, we're going to have different channel counts, lower channel counts, sample rate, and different latencies between 4 minimum up to 10 milliseconds. Important to say that all those platforms will share the same control layer mechanism, which is they will all support Dante controller, DDM, and updates. And then we have just added that there as a hint because it's something that is not available yet, but we are developing a product that is going to have a GraphQL API that is going to be allowing you to automate things on the Dante network. And just to give you an example of one customer using Dante application library, which is Dante for Windows or Mac, is Iris Audio. They have just embedded Dante application library within their application, so they get the audio directly from any Dante source on the network into their application. They perform some audio improvement, take the noise out of it. It's used on Formula 1 cars. And then they deliver that cleared up audio to broadcasters. And let's get started with Dante application library. So please, Andy, come to stage.
Thank you, Lucas. Okay. So I'm going to just walk you through the first few steps you need to get DAL into your app. So DAL is available as a download from Audinate, and you can license it, and then you have to do these 4 things. So first, we need to define our DAL config, and then we need to create an instance of that, and then we set an audio transfer callback, and then finally, we have to shut down explicitly when we're done. So first off, the config. So there's several, I've cut this down for brevity, but there's a few things we need to do to identify the product, and we can set version number and so forth that can match your own settings. Then we have to tell it which time source to use, and you probably want PTP because that's where we get the Dante goodness. Although if we're just doing a receiver, you can take the timestamps from the arrival of audio packets, and that works too. We need to tell it which Ethernet interface we're on. So you can either give it the name or you can give it the number of the interface, up to you. There are helper functions built into the Dante application library so that you can quiz that without having to write that bit for yourself. And then you want to tell it how many channels and what the names are, and then some information about your buffering. So you set the bit depth you want to be working at. And we've got two settings here, samples per period and periods per buffer. So if you were doing double buffering, that would be 2 periods, and 10 milliseconds at 48K would be 480 samples per period. And finally, I've put this list down to 1, but there's a whole bunch of protocols that we've got to set port numbers for. And this is important because we want port numbers that are different from other Dante products. So set your own private port numbers somewhere in the ephemeral port range, maybe 5,000 or so. Okay, so first, the next step is to create the DAL instance. So this is the function that does a lot of the heavy lifting here. We have to pass in our license token, and then this function goes off and creates all the supporting services that need to talk to the Dante network. And now we can create an actual instance of our DAL object, which takes the config we've just defined and this context variable as well that stores all the information. We have to check for activation. So the DAL application library is licensed. If it's not activated, we can't do a thing, so we have to bail. Finally, just call start. At that point, when we've called start, that's when you see your application turn up in the Dante controller. So this is the busy slide. We can get the audio interface from our DAL object, and then we have to set a transfer function that could be anything, but here I've just put it all into a lambda. So this gets called back whenever there's new packets arrived, if you're receiving, or it's basically every every buffer period. Sorry, we're having trouble with the audio. Yeah. Sorry. I'm trying, yeah. All right, sorry about that, guys. Yeah, so this gets called back every time we get a new buffer period. So we can get the properties, and that will basically return us things that we've set in the config. And here, the params available, available data buffer offsets in period, whatever that one's called. That tells you, if you're a receiver, that is the buffer that's full. If you're a transmitter, you want to be filling in the next one, so I've got a +1 there. And this is the number of samples we send, so I've just decided we're going to send the whole next buffer here. And the offset is given by another field here. So this is the offset into the transmit buffer. So what I'm doing here, I'm just looping through all the channels. We've got an output buffer that I've called Dante samples, which again we get from the properties. And we've got this output buffer, that's from our own app, wherever that is, and we just go through all the samples and copy them over. And obviously your application will have a much more efficient way to do all of this. Yeah. Oh, I forgot to mention, we're sending audio packets over the network, so we need to send them in network order. So that's typically a call to HTONL or something like that. But you want to do that in the conversion stage to make it more efficient. And finally, when you stop, we have to tell it. So I believe that the stop will get called automatically when we nullify the null pointer, but the supporting binaries and services must be shut down because they have no knowledge of our application, so we have to tell them explicitly. I've lost my next slide. There we go. And this is the demo of it at the booth. So we just set up a little JUCE app there. That's like the basic JUCE synth, but I've wired in the Dante application library. And this is a D-meter third-party DAL application. And those two channels there are audio coming from JUCE across the network through the, you've got a little cheap USB Ethernet adapter there and that red cable, and then into the switch that's behind the laptop there and back into the next PC. And finally, I think we've seen something like this before, but you can control all of this through the regular Dante controller routing matrix. So pretty much on the left here, we've got all the receivers, and at the top, we've got all the transmitters, and you can route any channel to any other channel. And you can also send channels as a multicast signal, and that means that multiple receivers can get the same signal, so you can send the same sound to multiple speaker arrays or something like that. Okay, if you want more information, that's the magic code. Someone said there was beer involved, but you can definitely get the DAL trial pack, which has a temporary license, so you can try it all out. And there's a few other links there for you as well.
Yeah, feel free to go to the Audinate website and register into the training section, because we offer 3 levels of certification for free. So if you want to know how Dante works and get a little bit of more information on it, go to the training website, register. There are just small videos that you can follow whenever you want, and there's a small quiz at the end. So as a start point, it's fantastic.
Thank you. We have some time for a little bit of questions. Ellen online wants to know, are there any DAWs with Dante support? Any DAWs with Dante support?
With native Dante support with DAL, no, not at this time.
But we do have the Dante Virtual Sound Card, which will give you an ASIO driver on Windows
or a Core Audio on Mac,
yeah.
And then you can use whatever DAW you want. That's the usual way of getting a DAW, Dante in and out of a DAW.
Could it exist in the audio plugin level?
Absolutely, yes.
With
yes.
this? With Dante application library.
One of the links on there, that one at the bottom, Dante JUCE demo, that's a member of the Dante community who's made a little plugin that, gets audio off the network and then sends it to whatever VST or AU plugin you want.
Awesome. Anybody? Oh, we got some questions right here.
So do I get it right that the Dante application library actually spins up its own audio thread who handles all the callback stuff, etc.? So this is what the Lambda is called on?
Yes. So in here, we've got this audio interface. So that will have its own thread. And there is a necessary copy in this situation because we can't know what your memory sharing constraints are. So at this point, you generate your signal and there's a single copy into the Dante buffer here. And you don't have control over when this thread gets called back, but it's kind of like the ASIO callback that gets, delivered by your driver manufacturer. Same kind of principle.
Yeah, and something that we didn't say is that you only can have one Dante virtual sound card running on one computer. However, with DAL, you can have multiple instances of DAL running simultaneously alongside with DVS. You can have DVS plus DAL 1, 2, 3, 4, whatever. They can coexist because they will appear as different Dante devices.
Is there any way of accessing the socket control data through this API, say for like mic preamp gain and that sort of control data?
Not yet. So it's a thing we want to introduce, right? We've got audio going over the Dante network and now video. And the next step is to get all the control data. And what we're thinking is some sort of simple pass-through and, the ability, another API, so that you can write a plugin that you can access through Dante Controller. And if it's there as a plugin, it's scriptable and whatever. The idea being you can still do your control however your app would normally do it, but you've got the option to put it all into the same control panel and then up to the Dante Domain Manager Cloud APIs or whatever in the fullness of time.
Hi, do I understand correctly that the computer running Dante doesn't need hardware, you're just communicating over the Ethernet jack, or do you need some audio interface with, okay.
Yeah. Oh, sorry. Yes, you definitely need, this is wired Ethernet only, so yeah, you'll need an Ethernet port either on your PC, or it works perfectly well with USB dongles. That's how I normally run it.
Yeah. A small dongle.
Yeah.
I mean, Dante only runs on Ethernet, not on Wi-Fi, because as you were saying before, Wi-Fi.
But yeah, sorry, that was the first part I wanted to just clarify. But the second part you're asking about, we need Danteized hardware on the network, yeah? And yes, that's true. If you want to use the PTP format, there's got to be a Dante box somewhere in there that is the clock master. All this it configures itself. So, if you've got a huge Dante system, you can configure it just so and nominate who is the clock master and that kind of thing. But straight out of the box, we use MDNS, and each device will kind of advertise how good a clock it has. And, there's a negotiation, and some device gets chosen as the clock master. And then that is broadcast via PTP to every other device on your network. Does that answer the question? Yeah, cool. Oh, sorry.
Do you plan to add MIDI to?
I don't think so.
No.
Well, with the there are plans on extending the control side of things, but I don't think MIDI is not even on plan anywhere.
Yeah, what we're not planning on doing is, doing our own implementation of, say, Dante MIDI. But what we might be considering is passing your MIDI bus over, so you can link this device to that device in Dante controller, and it will just route the signals one to another. And the Dante transport doesn't know anything about what's in that signal, but we could envisage it being connected via the controller.
Yeah, understand. You will see anyway a virtual MIDI device appearing, or is just pass through.
Probably a pass-through. So we're going to, we'd give you the API to write each end of that, if you like, so you can make it do what you want.
Awesome. Thank you very much. Let's give it up. We have one last one.
Oh, yeah.
Okay. And then I think we'll wrap it up with this one.
Just a quick question about the running in a plugin. So on macOS especially, when you're running in a plugin and you have all these exciting notarizing capabilities, so is the network actually happens in a thread that is being forked from the DAO process? So I need to expect the host to have permissions for network access, or you're running?
So, you have to set up your app, however you do that, with whatever permissions you need. I mean, I've not tried this on the Mac. But say on Windows, you have to allow all the ports to be open and that kind of thing. So as I said earlier, we don't actually, we won't be spawning a thread from your DAW environment or anything like that. There's an independent thread in a different process that we're running.
So the DAO is actually a separate process.
That's right. Yes, there's 2 or 3 supporting binaries
that you are
run
IPCing or something.
Exactly.
Okay.
Just independent processes.
Thank you.
Yep.
All right. Thank you. And if you have any other questions or anything like that, you can talk to them at their booth, right? Down the hall?
Yep, that's right. We're in the far corner.
In the far corner?
Yep.
All right. Thank you.
All right. Thank you.